All right, let's get started. Hi, everybody. Thank you so much for coming to our webinar today. I'm super excited about what we're going to be discussing today, Kubernetes security. It's a very important topic, and I believe it's one of the topics that keeps most of us awake at night in our various companies. So welcome wherever you are joining in from. I'm super excited you found time to attend our webinar. My name is Kennedy Tokura. I'm one of the founders at Mitigant and also the CTO. Mitigant is a cloud security company. We are based in Potsdam. It's a small town close to Berlin in Germany. And we do different kinds of cloud security things, including CSPM, KSPM, which is Kubernetes security and attack emulation. But talking about today's webinar, we have Thomas Fricke in our midst. He's going to be presenting to us from his rich experience about Kubernetes security, the problem space, solutions, and quite a lot of things. I'm pretty sure it's going to be a fun time. You might have noticed that the your mics are kind of actually disabled, so we just wanted to kind of keep a little bit of sanity, but please feel free to drop any questions you might have in the chat. Also, this session is being recorded, so you will have a copy of the recording afterwards. And we will also have a question and answer session afterwards, about 10 to 15 minutes, so that we can share feedback. If you have any questions, if you want to ask them directly, please hold on to them if you want, and we will also talk about or discuss them at the end of the webinar. So without wasting time, I will allow Thomas Fricke to take over now, and let's let the fun begin.
Yeah, thank you, Kennedy. So I'm also the founder of, one of the founders of Mitigant. So we started getting into it and saw a lot of common problems also in standard clouds. I've done Kubernetes security for some years. So that's me. Mostly I do Kubernetes in critical infrastructure, energy, healthcare, the German government, which is kind of fun. I have had several pro bono memberships and gave also advice how to create open code, so the German GitLab. I've been in the IT Planning Council, and now I have customers from the government, especially in the security relevant area. Yeah, what is Kubernetes security? You have more or less two choices. You can either manage the chaos by chaos engineering, chaos security engineering, or try to regain control. Depending on in what environment I am more or less on the one or the other side. So Mitigant tries to do the chaos security engineering part, and if I'm in a highly regulated environment, I try to regain control by GitOps, signing containers, signing artifacts in the build chain, and everything else. So if you have seen something from the security point of view, normally you have a picture like this. These are the network security zones of the government or of big companies. You have here the internet, and then here is the most restricted high security zone, and you have different zones to go from the innermost zone to high security zone, then a client security zone, then you have normally here a demilitarized zone, several extranets and so on, management plane on all that stuff. So you have more or less a picture like this. This is a standard you find in critical environments. And if you want to map every zone to a dedicated laptop, which is sometimes the case, and some people have 5 laptops in their pocket, which is quite a workload. Effectively, what we see here is this is more or less the design of this common network security. So this is a medieval castle. We have one mode, several walls, towers, bridges for access. And actually, these are quite stable. So this is Belvoir Castle. It took 18 months of siege to get access to the innermost part, and then they surrendered because they run out of resources. But if you go into Kubernetes, the battleground is quite different. You have pods coming and going, and this looks more or less like a battle on the sea, which means, it's virtually impossible to have here kind of molds or walls inside. And everything is very dynamic, so you have to be aware that you have to check everything in a dynamic way. This is more or less a standard in every cloud environment. If you want to create modes and walls, then you have this kind of thing. This is very expensive. So the typical carrier group is a carrier protected by lots of surrounding ships, which are more or less a mobile version of the mode. We go into that direction. Sorry for the military metaphors, but this comes closest to what we want to build in Kubernetes. And in the future, we have seen this already. This is some kind of an old slide. We see more mobile attacks and more agile attacks, and that this will look like drones. And unfortunately, we're seeing this everything in current wars. If you look deeper into Kubernetes, you have more or less your application. I have a standard application just for testing, which is kind of a vulnerable version of ImageMagick. Then you have your containers. You have your Kubernetes service accounts, your Kubernetes clusters, you have your nodes, and you have maybe your cloud service accounts if you run everything in the cloud. So you have a full stack of things which might be interesting for your attacker. You are writing, if you are a developer, you are writing this kind of application, and then you rely on container security, Kubernetes security, and the cloud security of your cloud provider, which is, quite a stack of things you have to trust in this environment. And everything is mobile, so pods are coming and going, and you rely on more or less everything. And if you ask the very standard question from a hacker's point of perspective, and there are capture the flag events on KubeCon, on everywhere, can my cluster be owned? And then the next question is, how many walls and barriers do you have in a Kubernetes cluster? And if you do things like protecting them, how far away are you from being hacked? So the first is your application. If you have Log4Shell in the Log4j environment, then you have obviously a vulnerability in the application, and you need additional measures to fix them. Here we use, my standard example is ImageTragic. You have a vulnerable version of an image converter, and you can use it to exec code inside the container. ImageMagick, effectively, this is a funny thing. It uses GhostScript, and when I made GhostScript the first time, this was 30 years ago, security was broken immediately. By looking into the make files, I discovered, hey, in the make file of GhostScript, you can have a switch which is on by default, execute arbitrary code. And from time to time, if a new developer takes over the maintenance of GhostScript, it may happen that there are other versions of GhostScript which are vulnerable, and GhostScript is inside something inside ImageMagick, and then you get this vulnerability, which is quite, quite the oldest one I know, which is still active from time to time. So the next thing is a Kubernetes design flaw, but it has been fixed after I gave this talk, or a similar talk, 2 years ago in Berlin in the C-base, and the service account gives you a service account token. The service account token has the rights of doing anything which you can do with this service account, and by default the service account token is mounted in your container. If your container is vulnerable, then you have given someone access to the service account token, and this means at least he or she can do requests to the API server, which have the same rights as the service account token has. So this means the next limitation is, what can we do with this service account token? It should be restricted somehow, but yeah, if you are in the cluster or in the container, in many containers which are not minimal, you can install other software. Normally, you already have a curl or a change mod or something executable, and you can install additional software in that container quite easily. You can download a kubectl, or you can even use a curl, and there are even people outside which can do things with cat and echo, where they can open arbitrary connections, and if this is not protected somehow. And here we see the image creators are affected. If you use a rich image because you are used to using kind of whatever Red Hat, Ubuntu, Microsoft image, which are effectively Debian images, if you don't care about it, then you have additional tools in that. kubectl can normally must be downloaded, but curl and change mod are quite popular in containers. And then if some of you or your colleague makes a mistake by simply copying things from the internet, you get total control. If you, by accident or by not knowing what you are doing, if you create a role binding from this service account to the cluster admin role. This means then, yeah, the internet is responsible, so that means nobody is responsible. You see installation procedures from some vendors, which still up to date require role binding to cluster admin role. You can get this in a Helm chart if you don't care about your Helm charts and install it just on the fly, and then you have more or less a vulnerability from the application via the service account, installing extra software to the cluster admin role. And this means if you have these steps all together, then your cluster can be owned by somebody from outside through the application request, through the internet, and you get access to the cluster admin role. Here is an example which is still working. Just look for this, if we can do this. So this is still an official installation requirement, which is outdated. The new version is available, but if you don't notice this, then you get still this installation outdated version, and then you have the cluster admin role. Okay, back to the presentation. And yeah, so please never follow these practices without reviewing them, and it comes also in Helm charts, for example, from the cluster admin role in the Apache incubator. Just checking, no, it's not. This website is so outdated, it does not apply anymore. So that's something you have in mind. Please review your Helm charts as if you don't create them yourself, and any depending on charts. So the next step, this means if we have all 4 things together, then yeah, you can be owned. We had seen the same with log4shell, so it's more or less an equivalent as if you have placed the door key under the doormat or something else. You give free access to your cluster if you do this. In the case you are interested, or you have enough time at the end, we can do an example walkthrough. But this has been done with OpenShift 4 in a nutshell. It's a little bit challenging, but because people always say, okay, the Red Hat ecosystem is so secure, you cannot hack it. I did it on OpenShift simply just to show that there is no difference. And the Jupyter notebooks are available, so I have all the notebooks I normally do in Kubernetes security trainings available on GitHub. And here is a picture you put. So this is it's a valid ImageMagick image. So this means you push this image to the ImageMagick server, and then you want to tell them, okay, please use this URL. This must be adapted to your local environment. And then you can simply do a curl output file kubectl here, and then you install the, well, probably this is not the latest version, but then you have the version you need on your cluster. And then you have installed in the temp file, because temp file normally is writable even if your container is read-only. Then you have a valid kubectl in your container, and then this is a picture, and you can do this. Here is the Jupyter notebook, just to show you. Here's a full attack. So how to build an image tragic, how to do an image, how to do the exploit, and this is the overview notebook, just to show you this is not some code which cannot be executed. So normally I use Jupyter notebooks for the training because some of the attacks are a little bit complicated to do in a bash-only environment, and this helps me to keep track on complex environment settings and so on. Here is the exploit, or the result of the exploit. And if you see, I can do a deployment here, I can create a service, this is the normal stuff. And here we have these pictures. So this is how I upload the pictures. And here is the cluster role binding, which is required by this outdated Elasticsearch installation, and then you get access to that kind of container. You see the ports. It's possible to deploy arbitrary containers here, and I just call them evil malware, but this is obviously some not so evil part. What? Back to the presentation. And yeah, how can we do the fix? So this is the Red Hat way of fixing this. They have an image health index, but even the healthiest images have all this curl part inside. So I just cared about it that this curl command also works in the grade A health index images, so this is not really a protection. What they offer instead is some mitigation of that. So they scan the images earlier times by Clear, now by Trivy, and now they have stack rocks. And if some container does something unusual, they would kill the container. But neither Trivy nor stack rocks have a problem with the curl inside the container. Yeah, these are the good practices. Red Hat images apply, no root inside. It's an immutable root file system, but still we can go to the internet, have write access to the temp file, and have a valid change mod command inside. Why does your application need a change mod? Normally, it does not. It's just convenience for developers, and you should definitely think about hardening your application and not exposing change mod and system tools like that to developers, even if they have only the right or no root inside. This has worked. So let's try to fix it. If this has not happened, and if you have the latest versions of Kubernetes, the service account token should not be present in your container. This was some escalation to Red Hat security, and then I think they escalated it to the kubectl community, Kubernetes community, and now the service amount token is history. So this is, you should not need it, but then I've seen also clusters in the cloud, mainly Azure clusters, where this is still open, even if the version of the Kubernetes should not mount this token. So please look if your auto-mount service account token is still there. If you are not running an operator, you don't need it. If you are running an operator, the operator in production environment should not be exposed to the internet. Either you have an operator or connection to the internet. This is a good architecture advice. Here is a Jupyter notebook on that. Service account token, but be aware this can be overwritten if a pod requires explicitly the service account token. So this is not a silver bullet. You still have to look for the service account token in your pods if you are running unknown containers. So we have fixed that. Your application is still in your responsibility. And now go deeper to the images. You need really immutable images. Only temp if you need this. You don't need /run. Your PID is normally 1 anyway. You don't need /var because you have normally not variable data inside. So what you should really use are containers from scratch. Without curl, wget, even Red Hat UBI should not be used. And most of the standard images are flawed. If I go to a customer, the first thing I do is, yes, because these are the slowest processes and the developers need some time and they need to be pre-warned. Let's scan your container, and normally you have in Red Hat or Microsoft-based .NET containers typically 130, 140 security flaws. And then the discussion starts, yes, but this Python version inside is not really used. Yeah, why is it there? Is the question next, and what shall we do? And if you go to the security guys, they have normally not very much experience with Kubernetes. They get a lot of false alerts. So this means the security, which is already overloaded with tasks, is blinded by false positives, which only can use if somebody else gets access to the container image. So recommend is build your own images. What you can also do, this is an example, some warning at the end, you can do a container hardening. And this means I have a script, and hardening script is also available for Nginx. on GitHub, you see you have a hardening script, and the hardening script is good old Bourne shell script. If you have never seen Bourne shell, then this is your chance. There's no bash inside. Bash is much too bloated for Alpine. So this is even hardening Alpine images. And what we see here is it gets a positive list on the command line, which means only these things which are really needed by my application are inside the container. And the library where other libraries are included automatically. So if you have a library, the -d, the dynamical library linked files are there by using a library analysis. Oh, some people seem to like this. Okay. The next step is, find out what your application really needs, and then the reward for that is your containers is now shrinking to 6 megabytes in the case of Nginx, or dramatically shrinking. You can use it for a lot of opportunities. Much better would be to use a statically compiled version of Nginx, but then you have the effort to compile it, and you have then the opportunity to run an even harder version. Then you use, in a different stage, you use from scratch, copy all the stuff we have put in the hardened directory here, and then use the entry point Nginx, and then have a hardened version of Nginx. You can do this with a lot of languages. I think it's even possible for .NET, but .NET has not dynamical libraries. They are doing an an LD open call, and then you have to analyze dependencies on yourself. But I think there is even a .NET version available where you can have a standalone file that you can even avoid this mess here and just put a statically linked .NET library in there. Other things with Java, Quarkus and Graal and things like this, that you have really a minimal image here without all the stuff. This was too fast. Okay, no. So we have killed all the unnecessary stuff in our image, and now the role binding to the cluster admin role. Yeah, we can analyze this just to be sure that there is no role binding to the cluster admin role, but we have to do this. I skip this because of the kubectl command. This is also on my GitHub, in my GitHub trainings, but you can use it on your own. It's quite a one-liner, a very long one. The next step I already mentioned is separate network and privileges. What we also see very often is, yes, you have a very privileged application, and for whatever convenience, you have kind of connection to the internet. Again, we had this very old example of Elasticsearch, where everything was done quite wrong, and here you see what they what they did in the first step is they had integrated both things. So they did an init call to the host just to reserve more memory for a certain for the database, and then this must be a privileged call. But this is in the meantime, it made a move into the kubectl or in the Kubernetes definition, so it's not necessary, and you don't need it. And what they made, the mistakes they made, then the entire application has run with these privileges you needed just for the sysctl call, and this is wrong. The right solution is here. Have an init container, well, something is done, let's say copying things from another database or the file system, then you run your main application, then you apply, or let Kubernetes apply network policies. This is additionally isolated in Kubernetes, and then you can connect your application to the internet. And in these stages, the ready stage is the stage where you have where it's getting critical, but you don't need this both in one picture. This was a mistake. So this is the right approach here. And do especially privileged applications in other namespaces that you can isolate them further. Answers here are network policies and separation of concerns. So the privileges from the, I expose everything to the internet. So if you would do it in a threat matrix, if nothing is exposed and everything is unprivileged yet, then you have to do nothing to do. If something is exposed, then you have a web application, you don't need privileges. If something is really privileged, that you have an operator, sysctl card, build, host operators, GitOps, and things like this, then you should care. And if you have, for example, where this might be necessary, if you have an IDE or something like RStudio or a GitOps web UI, then you have an exposed service which is also privileged. Here you have to care a lot that you did not have something really critical exposed to the internet. Okay, we have taken control about this now, and then I think we have more or less fixed everything we can fix, except your application. Of course, this is what you have to do as a developer, or your developers. They have to fix their application. This cannot be done by Kubernetes themselves. Fixing images. For example, if you see scanning applications, here you have Trivy inside Harbor. You can run it as your proxy to the outside world. Perhaps you are already doing it. If you are doing Docker Hub, and here you see this was a typical, yes, out-of-the-box Tomcat. And they have not fixed anything. And here you see all this stuff you don't need. Here, curl, libfree, and then your container is critical, and you have to discuss it here, what you really need and what you not need. Probably in a Tomcat, you don't need a Python minimal something, a distribution or something like this. So please clean it up before it goes this way. Then otherwise, automatically have here the challenge either to refuse this container or to discuss every of these CVEs with the security. So my personal record was an application where somebody has put a development environment in the container and delivered it as a container to critical environment with 700 and more vulnerabilities. As I already mentioned, typically you have 150, and I would say scanners you cannot navigate with a vulnerability scanner, and even the best vendors have the problem. And it's please stop containers using like VMs. These are not virtual machines. You should look into 12-factor, what you really need. You use, as I said, distro-less image, hardening images, things like this. And this is indeed some education you need. If you want to deliver applications for a critical environment and have to follow German or other security standards, you have to do it anyway, because in any CIS standard for containers or in the German BSI Grundschutz standards, you are required to do this and to exclude all these unwanted applications. And then if you do also this, then yeah, we are completely green, and can be sure that at least from the outside our containers or our cluster cannot be hacked. As usual, more isolation is possible. Already mentioned network policies, so egress policies. You can also use Istio or any other service mesh for that. You can use a node to use SecCom and restrict the access to a certain system calls. You can use different different container runtime like gvisor, which eliminates the possibility of doing certain things inside your cluster. You can also use SE Linux or AppArmor for that. And you should definitely use port security policies for this. You have already a lot of things in the Open Policy Agent. And you should also use to isolate your service accounts, individual service accounts for every task in your cluster. They have to deal with role-based access controls. This is not fun, therefore I'm not presenting it, but you should have somebody in in your team which at least understands roles and role-based access control. There is at the moment a common practice that you should have security champions in your team. At least, so security champions, if you are a developer, at least every team should have one developer who is aware of the security that you can ask them. Not everybody needs this, but maybe she is available for you, and this is then the start of your journey into DevSecOps. Yeah, you should also look what are you delivering. So this is required by law in the near future that you get SBOMs, and if you create containers that you create also the SBOMs to your customers. This is not a nice to have. You have to do this or you have to receive it. And you need this for open source license compliance anyway. And now in the near future, you also need this for the security in Europe. So what does it mean? SBOM software bill of materials is just kind of a bill of material list for your software, because we have total loss of control. I've been in a meeting founding or supporting the sovereign tech firm. Yes, we want to support it. Yes, we want to throw money on the sovereign tech firm because they do a good job on fixing open source software, but we only want to support the projects we really need. Yeah, what projects are you in need of? We don't know. Yeah, show me your SBOM. What is an SBOM? So this should be fixed now, but you need, if you want to support an open source project, you will find an SBOM which ones you are really needing, and probably you are already using Log4j. And good news of today, Sovereign Tech Forum is supporting Log4j because it's more or less omnipresent. Yeah, this was the Log4j story. Are we affected? Look into your SBOM. What is an SBOM? No idea. Do you use Java? Yes, then you are probably affected. So this was a story a few years ago, and it's still true, unfortunately. We see 30% of the projects, depending on Log4j, are using vulnerable versions of that. So if you want to take back control, please scan every image, every artifact in programming language, Python, Java, .NET. They have full-fledged environments. Please also check every configuration in GitOps. If you have vendors which are delivering software to you, make them sign the software that you get signed software in the future. You should also use a signed Git for critical infrastructure, for example, Gitty or the follower, I forgot the name in the moment. And in every cluster, you should have for every cluster you should probably have, if you have running many clusters and you need to run air-gapped, you should have a dedicated management cluster. And the gatekeeper can be in Harbor also Trivy, because Harbor can check signatures. Trivy is scanning your containers for vulnerabilities, and then you are on the more or less safe side. Signing is possible. You can do this with cosign. I just mentioned it. It's using GPG. You can sign images. A lot of packages at the moment. You can sign Helm charts and Git commits, and then you have a stack of Harbor images, Argo CD, and for example, a container runtime which is aware of signatures that you only can run signed containers. You can also do this with a with a controller that you only allow signed images, because not everybody is running CRIO. Then you have a secure deployment chain, container runtime designs. This is my preferred way. The other way is if you are for some reason bound to Docker. I don't know actually a reason why, except your Kubernetes vendor does not support it. You can have an admission controller for the same role, but effectively this is not necessary. And then you can have tools which are propagating only signed images, configs, and charts. Here is an example picture of the entire thing. Here is the outside world, and then we are scanning everything and only promoting containers to the inner air-gapped clusters, which are scanned, and configuration comes from Git, and Argo CD is delivering them. So Argo CD then has all the credentials, of course, all the containers. And everything, if something goes wrong, is reported to your favorite logging tool. That might be Splunk if you have some money, might be Elastic if you have the workforce to do it. But that's actually what I recommend in critical infrastructure. Here, for example, is Argo CD. So you see the delivery, and you are also possible to do the Kubernetes delivery if the people who are managing the delivery only have, let's say, a limited knowledge of command lines. This is the way you define an Argo CD application. It's more or less a server together with a repository. And here you say, please deploy this repo to this server, and then it's running your application there. So it's not rocket science if you have installed it. This is a way of signing containers, so just for demo. So it's also not rocket science. The links are always in the slides. And behind the scenes, what we are aiming for is kind of an environment where everything is signed. And this is important for large Kubernetes clusters with a lot of application in critical infrastructure, where you have here the developers which are authenticated to with OpenID Connect. This can also be anonymous. And then you get a certificate, and this is it has a short time of life, so it is only for this case that you get a private key, and it is a certificate. And then you publish the signing certificate. This is also done in transparency log, that you know everything which has been signed with your keys is in that log. And then at the end, the cluster or the end users are checking this, and it's all monitored. And that's what in the future we will have in restricted environments instead of the unsecurity. But this will take, I think, at least a few years in the future. So let's start signing step by step, Git signing and the build artifacts, and then promote and protect the build system itself. Okay, and then you can do the same setup with checking signatures. This is called continuous security monitoring. Everything is signed and it is checked that everything is signed if you are in highly secure environments. Okay, hardening I already mentioned. And another thing is AppCo, but it's, as far as I know, it only works for Alpine Linux. They have the Alpine Package Manager integrated that it understands OCI formats, and then you can do it more or less on the fly. If you like Alpine, what I effectively do, and then you see build files like this. You don't have this Docker build files, and get an SBOM for free, so you have a full-fledged environment which can be audited and checked. Cosine verification, you have all these stuff running here, and you get more or less the entire stack of compliance and security and all together. Okay, if you have questions, then you can contact me or through Kennedy, and I should also have mentioned my Mitigant address, thomas@mitigant.io. Find me on Mastodon, on LinkedIn. If you need information about the trainings, it's all on GitHub, and hardening in the management cluster. This is all on GitHub. Yeah, we are coming to an end. Thank you for your attention. I'm happy for your questions. Happy to hear your questions. Hope you.
Right. Thank you so much, Thomas. That was a very super packed session. I would say a lot of information you already provided. So I believe there'll be questions, I believe. So thank you so much, Thomas. So let's move to the next part of this webinar, which is the interactive session. We will basically right now stop recording and also enable the mics